Hello students, welcome to Educate. Today we will do numericals on the chapter Thermodynamics. So let's see these questions. These questions are from NCERT textbook. Question 1 says, a geyser heats water flowing at the rate of 3 liter per minute from 27 degree to 77 degree. If the geyser operates on a gas burner, what is the rate of consumption of the fuel if its heat of combustion is 4 into 10 power 4 joule per gram? Question is simple if you analyze. So here you have to find out what amount of heat is consumed, then what amount of fuel will be consumed, then you can easily find the rate. So let's see. As per the information here, we are given mass. What is mass? 3 liter, which is equal to 3 kg, and rate per minute, right? So our answer will also be per minute. So we are writing just 3 liter, that is 3 kg, and information about temperature is also given. Temperature change delta T is equal to 77 minus 27, that is 50 degree centigrade, right? Now here one more information is needed, that is specific heat. So specific heat of water we can take C as 4.2 into 10 power 3. If we take it in gram, so that will be better, because here this is given in gram, this we can write in terms of gram, so question will become easier. So in place of 3 kg we can write 3000 gram. Here why mass is 3000 gram? Because 3 liter 1 liter equal to 1 kg for water, right? Because density is 1000 kg per meter cube, and other informations are in CGS, so it will become simple. So in that case we can take specific heat as 4.2 into 10 power 3, that will be MKS. So here we are using CGS, so just write 4.2 joule per gram. Now we have sufficient information, so we can write the formula for Q equal to MC delta T, right? So if we put the values, M is 3000 into specific heat is 4.2 into temperature change, that is 50. So this much joule per minute, right? Now we have to find out what is fuel consumption. So energy released by fuel is 4 into 10 power 4 joule per gram. So we can easily find, so mass of fuel per minute or rate of fuel consumption. So heat required per minute divided by heat given out. So heat required is 3000 multiplied by 4.2 multiplied by 50 divided by this value 4 into 10 to the power 4, and hence we will get it in gram per minute, right? So we can evaluate it. So zeros we can consider 1 2 3 4 zeros will cancel out by this, so we will be left with 3 into 4.2 3 into 4.2 into 5 divided by 4, right? We can simplify. So this will become how much? This 4 5s are 20 and this 0 and this is 21, right? And 21 into 3 divided by denominator is 4, then it will become 63 by 4, and then you can write gram per minute. So it will become 15.75 gram per minute. I think you have understood. Question is not tough. Now let's go to second question. Second question says, what amount of heat must be supplied to 2 into 10 power minus 2 kg of nitrogen at room temperature to rise its temperature by 45 degrees centigrade at constant pressure, given molecular weight of nitrogen at room temperature is 28 and R equal to 8.3 joule per mole per Kelvin, and value of Cp is also given. So let's see how to solve it. So question is simple. Just we have to write the information. So information is given. So we can convert the given mass into mole. So first of all, we have to find out number of moles. So number of moles will be given mass 2 into 10 power minus 2 divided by molecular mass, and that is given here in our question, that it is 28, right? That is in terms of, this is in terms of kg, this is in terms of gram, right? So here if you convert into gram, so you have to multiply by 1000, then 2 zeros will cancel out. You will be left with 20 upon 28, correct? Or half, you can write it 5 and this 7. So 5 by 7 moles. And now what more heat supplied we have to find out. So Q is equal to N times Cp, specific heat at constant pressure, and then change in temperature we need. So N is 5 by 7 and the Cp, specific heat, is given 7 by 2R, where R is 8.3. So 7 by 2 into R, R is 8.3 we can write, and then multiplied by change in temperature. Temperature is 45 degrees centigrade. So just write 45 here. Now simplify. So here 7 will cancel out. Then this can be written as 2.5. So 2.5 multiplied by 8.3 multiplied by 45. Now let's multiply it. So if we multiply, we will get 933.75 joule. Question is simple. Q equal to mc delta T generally we apply, but here if it is given in mole, in that case this is also specific heat at constant pressure is given in our question. Here it said Cp equal to 7 by 2R, and that we have used here to get the answer, right? So let's take next question. Explain why two bodies at different temperatures, say T1 and T2, if brought in thermal contact, do not necessarily settle to mean temperature T1 plus T2 divided by 2. It is obvious. If they have same heat capacities and if they have same specific heats, in that case it is possible. Here they may differ in thermal capacities, correct? So here you can see the answer. the two bodies may have different masses and different materials, that is, they may have different thermal capacities. In case the two bodies have equal thermal capacities, they would settle at the mean temperature T1 plus T2 divided by 2. So you have understood? If thermal capacities are equal, in that case, they can settle at mean temperature. Otherwise, no. Second point is, the coolant in a chemical or a nuclear plant, that is liquid used to prevent the different parts of plant from getting too hot, should have high specific heat. Of course, if material has high specific heat, then most of the heat it will absorb. The same is true here. The purpose of coolant is to absorb maximum heat with least rise in its own temperature. This is possible only if specific heat is high. From formula this, Q equal to mc delta T. For a given value of m and Q, the rise in temperature delta T will be small if C is large. This will prevent different parts of nuclear reactor from getting too hot. So let's analyze the formula. Formula says Q equal to mc delta T. Right. So here, if C will be large, in that case Q will be large, means heat absorbed will be more. So water is the best fit material. It has highest specific heat, right? So here, what is the question? That coolant, generally in nuclear reactor, coolant used is deuterium oxide, D2O, or heavy water, right? That you will study in chapter nucleus in class 12 physics. Now let's analyze next question. Air pressure in a car tire increases during driving. So it is general observation. Suppose this is air particle, this is air particle, and suppose they are in container, then what will happen? So if it is heated, in that case they will acquire more and more with thermal velocities. So that is why they will exert more pressure on the wall of the container, hence temperature will rise. So here in question it is said that air pressure in a car tire increases during driving. So since there will be friction between road and the tire, so temperature will increase and hence internal energy will increase, and thereby more collisions will be there with the surface, that is with the tire, and then obviously it will cause increase in pressure. So here it's a given, due to the friction between the tires and the road, the tires get heated, the temperature of air inside the tires increase, consequently the air pressure in the tires increases slightly. And next part says the climate of a harbor town is more temperate than that of town in a desert at the same altitude. So the relative humidity of a harbor town is more than that of desert town due to high specific heat, not this beat, it's a mistake. Due to high specific heat of water, the variation in the temperature of humid air are less. Hence, the climate of harbor town is without the extreme of hot or cold, right? And let's see next question. Next question says, a cylinder with a movable piston contains 3 moles of hydrogen at a standard temperature and pressure. The walls of the cylinder are made of heat insulator and the piston is insulated by having a pile of sand on it. What factor does the pressure of the gas increase if the gas is compressed to half of its volume? So here we have to find out by what factor the pressure of the gas increase. So let's find out what is happening here. So here the piston is insulated. It means we are talking about adiabatic process. So if adiabatic process is there, then its state equation is governed by coefficients equation, and that is given by PV power gamma equal to constant. Right. So we can generalize it. We can write P1 V1 power gamma equal to P2 V2 power gamma. Right. And in our question, information is given. If not given, so we can take here 1.4 as gamma. So there should be information about this question. Okay. Now here what is happening? 3 moles of hydrogen at standard temperature and pressure. The walls of the cylinder are made of heat, and the piston is by having pipes and by whatever does the pressure of the gas. If the gas is compressed to half of its original volume, so volume is changing. V becomes V by 2. Then what about P? Right. So from this formula, we can write, suppose we write P2 upon P1. Right. Then what do we get? It will become V1 upon V2 whole power gamma. No doubt. Now, here V2 becomes, V2 is equal to V by 2. So in place of V2, we can write V by 2. So just write V1 is say V, then V by 2 whole power gamma, and gamma is given as 1.4. Right. So 2 power 1.4. Now by using calculator, we can evaluate it. That will come out to be around 2.64. So our answer will be 2.64. Right. Question is simple. Only you have to use adiabatic equation, and then you can easily evaluate. Let's see next question. What is next question? It says, in changing the state of a gas adiabatically from an equilibrium state to another equilibrium state, A is first equilibrium state and B is another equilibrium state, an amount of work equal to 22.3 joule is done on the system. If the gas is taken from state A to B via a process in which the net heat absorbed by the system is 9.35 calorie. How much is the net work done by the system in the latter case? You can take 1 calorie equal to 4.19 joule. So first of all, here you have to think that system is, here adiabatic process is taking place. It means heat exchange is not possible. So you can write Q equal to 0, right? Or delta Q you can use. If you wish, you are using first law of thermodynamics, you can write delta Q equal to delta U plus just either PdV or just write W, right? But since Q equal to 0 in this question, delta Q equal to 0. So here question is, then an amount of work equal to this much is done on the system. Work done on the system is taken as negative. If you remember, I told you about the sign convention. So here work done is given as minus 22.3 joule. And what is from this formula? If we apply formula, so delta U plus W is equal to 0, right? From here, this is given, and we are given W as minus 22.3 equal to 0. So we can get delta U equal to 22.3 joule. So there is no doubt. Now, that question says, if the gas is taken from state A to B via a process in which the net heat absorbed by the system is 9.35 calorie. In this case, heat is being absorbed. So value of Q is positive, and that is equal to this much. So we can write value, either just write delta Q. delta Q is 9.35 calorie and 1 calorie equal to 4.19 joule. So this is Q. Again we apply same formula. So delta Q equal to delta U plus W. Right, and here we have to find out W. So W equal to delta Q minus delta U, and delta Q is this much, so this comes out to be 39.2 minus delta U we have just found, that is 22.3 joule. So we can make use of this. So 22.3 joule, and if we subtract the two we will get 16.9 joule. I think you have understood, and since work done is positive, it means work is done by the system, because when work is done on the system, then it is taken to be negative. Next question is, two cylinders A and B of equal capacity are connected to each other via a stopcock. The cylinder A contains a gas at standard temperature and pressure, while the cylinder B is completely evacuated. The entire system is thermally insulated. You have understood the question? Two cylinders A and B of equal capacity are connected to each other via a stopcock. The cylinder A situation is like this, that here one cylinder is given. Suppose this is cylinder, and there is another cylinder. Here there is stopcock which is preventing the two, and here there is another cylinder, right? So here there is vacuum, here there is nothing, and one contains cylinder A. Suppose this is cylinder A, this is cylinder B. Equal capacity are connected to each other via stopcock. The cylinder A contains a gas at standard temperature and pressure. Here there is gas, here there is nothing, here there is vacuum. Now system is thermally insulated. The stopcock is suddenly opened. What will happen? If a stopcock is suddenly opened, then gas will rush toward the vacuum, right? So case number one, what is final pressure of gas in A and B? Obviously, since the capacity of both the cylinders is the same, so gas will be equally distributed. So pressure will become just half. When the stopcock is suddenly opened, the volume available to the gas at 1 atm becomes twice the original volume, and hence pressure becomes half the original. PV equal to constant, right? So from there we get half P1 equal to P2 V2. Obviously, here what is happening? If V becomes a half, then this will get doubled, and hence we will get 0.5. The second part says, what is the change in internal energy of the gas? So here in the question it is indicated that system is thermally insulated. It means there is no exchange of energy from outside. So first term in first law of thermodynamics, delta Q equal to delta U plus W. Here this term will be 0. So this will be left. Here we are asking what is the value of as the system is thermally insulated, so delta Q equal to 0. Also the gas expands against 0 pressure, so delta W equal to 0. So work done will not be there, and hence by first law of thermodynamics, delta U is 0. There is no change in the internal energy of the gas. Then third part is, what is the change in temperature of the gas? So since internal energy is not changing, so temperature will also remain unchanged. Then comes, what is the change in temperature of the gas? Then comes, do the intermediate states of the system before settling to final equilibrium state lie on the PVT surface? So here the free expansion of the gas is very rapid, right? Hence cannot be controlled. The intermediate states are non-equilibrium states and do not satisfy the gas equation. In due course, the gas returns to equilibrium state, which lies on PVT surface. You have understood? So if process is slower, in that case you can say that it lies on the PVT surface. But if process is not slow, it means it's very rapid, in that case the intermediate states will not lie on the PVT surface. There must be some deviation. And now next question is there that says, and an electric heater supplies heat to a system at a rate of 100 watt. If system performs work at a rate of 75 joules per second, at what rate is the internal energy increasing? So question is very simple. Here we apply first law of thermodynamics, delta Q equal to delta U plus W. Right. Here question says that work done is 25. So this is 25 and we have to find out what is delta U, and delta Q is given 100 but not delta Q. Keep in mind it is given in terms of rate. Be careful. You have to reread the question. An electric heater supplies heat to a system at a rate of 100 watt. If system performs the work at the rate of 75 joule per second, then at what rate is the internal energy increasing? So when we apply the formula delta Q equal to delta U plus W, right? And if we want to convert this equation in terms of rate, so what do? We write delta Q upon, either we write small t, we can also write delta T, delta U by small t plus delta this W divided by small t. So what is our concern? Our concern is to get this, and here this is given as 100 and this is to be found, so delta U by T, and this is given as 25, not 25, sorry, it is given as 75. So we write 75. Now delta U by T is equal to 100 minus 75, that is 25 joule per second. I think you have understood it fully. Now let's go to next question. Next question says, a thermodynamic system is taken from an original state to an intermediate state by the linear process as shown. Correct? If you start from here, you will move like this. You can start from anywhere, right? So you have to move on the sides of triangle. So here work done in PV diagram is very simple. Find the area of the figure or area under this figure enclosed by the figure. So if you can use direct method or indirect method, anyone you can use. If you use indirect method, then you have to consider area under total area included by DHGE. So that will be area of trapezium. Then you have to exclude this area of rectangle FEGH. So it is better to find the area of this triangle directly half base into height. So if you find area half base is this much, base is 5 minus 2 into height is 600 minus 300, right? So it will become 1 by 2 into 3 into 300. This will be 450, right? And you have to find out work done, it means it will be joule. So this is answer. I think you have understood all questions properly. Thank you for watching. Team Educate.